Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I talk to Gordon Stiles, founder and president of Star Rapid, which manufactures components on demand using a combination of subtractive and additive manufacturing processes, meaning CNC machines and 3D printers, and a variety of other technologies.
My name's Gordon Stiles. I'm the founder and president, CEO of Star Rapid Limited. We're a Hong Kong-based company, which I own outright, and we have a subsidiary factory in China where most of our activity is carried on. And we're very much aligned with the 3D printing industry. We actually do metal 3D printing, but we have a much wider sort of service base. So we're doing CNC parts and tool making, injection molding, die casting. So it's kind of the broad spectrum of prototype and low volume manufacturing services that allows us to help product developers to get their products to market more efficiently, faster, with less issues. You know, that's what we do for our clients, you know, and we service about, we've got 300 people. We service about 1,000 clients a year, and we've got about 72,000 square feet here in Zhongshan in China.
It's a very interesting field. I mean, I personally find it prototyping and designing products and parts and things like that very, very interesting. I wish I could do it myself. What's the background? What's your background, and what's the background of the company? How did you start off, and what made you decide to go into this field?
Well, at the age of 18, I did an apprenticeship in my father's small, what you might call a mom and pop shop. It was doing sort of CNC milling, turning, that kind of thing, and did that for about 10 years. My father passed away. I took on the mantle of the family business. And by sort of 1992, 93, I was becoming very frustrated with being just another little jobbing shop, you know, making no money, going nowhere. And I started to read about this just magical process called 3D printing. It had only just been launched in around about 1987. The first usable machine was the 3D Systems stereolithography machine. And I read about it, saw it on TV, and I just dreamt about having some kind of magical machine like that that could grow parts out of a bath of liquid with laser beams. And it just seemed so high-tech, so Star Trek, because I'm a big Star Trek fan, not a Trekkie, but I'm a big fan. And I remember thinking, I have got to get myself one of those. That will transform my life. And as a 10-person company, I raised some money with a venture capitalist, and I went out and I bought myself an SLA 250. That's a stereolithography, laser-based, liquid resin system. Installed it in my little shop up in the northeast in Thornaby, Stockton-on-Tees, and we started advertising, and it literally transformed my life. It transformed the business. And I became, by the year 2000, in just 7 short years, but became the largest 3D printing company in the UK, and I guess at least the 2nd or 3rd largest in Europe at that time. It utterly transformed the life of product designers. We were literally overwhelmed with demand. It was very profitable back then. You know, nowadays you might pay, you know, I don't know, 60p for a gram converted. Back then it was, oh my goodness, it was £10 a gram. You know, it was so profitable, you can almost not imagine. But you know, by the 2000s, early 2000s, that profitability was waning, and it was going down to more normal kinds of profits. Anyway, I sold out that business in the year 2000. And I went off to do some precision engineering, some more of what I really knew, CNC machining. But that business, that second business of mine, got absolutely hammered because Chinese competition was coming online. And, you know, where we might need 225 pounds to make a part, this is a specific case, they were coming in at 25 quid. And I'm like, how is that even possible? That can't be possible. My material costs, my carbide costs are more than that. And it was a new business, you know, just 15 people doing about £1 million turnover. And we just got snuffed out, just snuffed. We couldn't survive against this onslaught of low-cost competition. So I decided to go to China and have a look and find out what on earth is it that the Chinese are doing to be able to kill a company like mine in under sort of a year. And I went there and I found out that they were indeed cheap, but they couldn't actually do what I did. And an awful lot of people got very badly damaged buying ultra low cost services from China back then in the sort of mid 2000s. But what I did learn is that if you were to do it for about half or 2/3 of the price, you could do a full Western quality standard job and still be competitive. And that's kind of what I planned to do. I wrote a business plan, shut the company in the UK, pretty much wiped out financially, got on a plane, went to China and set up a one-man business trading prototypes. And eventually within 4 years had my own factory, and the rest is history. We grew organically to 300 people with no further investment than about $5,000.
Right. I'm glad it's worked out for you, obviously. And I was interested in what you just said about the Chinese companies couldn't do what you did. If you could elaborate, I know you touched on quality and maybe other things, but what are the things that they couldn't do that you did?
Well, obviously it's a very different, I'll make it very clear, it's very different today, okay? But we're talking 14 years ago. China was significantly less developed than it is today. Their factories, certainly in my field, were very poorly capitalized. The skill levels were on the floor. Their machines were archaic. Even when they were new, they were 1960s, 70s technologies. They had little or no quality standards, certainly in shall we say, in the kind of supply base I could access and the kind of supply base that my customers in the UK could access. So they were just really, back then, you know, that they had a reputation for turning out very poor quality, and it was true. It really genuinely was true. Now, there were companies in China back then, obviously the likes of Foxconn and Flex and people like that, foreign-owned enterprises, and also some state-owned enterprises who had picked the cream off the top of the labor market, had invested very wisely, brought in all the latest techniques from whether it be Japan, Korea, Taiwan, you know, the Americas, wherever. And they were producing fabulous quality products. You know, Dell was all built in, you know, Shenzhen and Dongguan mostly. So, you know, if you were talking about very well invested, very well trained workforces where they'd skimmed the cream, yeah, they could actually do a good job. But that was more for mass market products where they could apply all these controls to, you know, mass production. But in my industry, which was really prototyping, low volume jobbing kind of work, CNC machining, no, in that level, there were almost no good suppliers back then. It's very different today. There's a lot of much better suppliers, and some that, frankly, their quality equals or exceeds some of the best in the world. But that's 14 years later.
I find many things interesting about the 3D printing technology. I share your enthusiasm for it, although, you know, I don't have the background that you do. But one of the things that sort of made me think that it's got a bit of a way to go is that the finishing, the surface isn't as smooth when you 3D print something. compared to injection molding something, which injection molding being I suppose the main way of mass manufacturing things. But what kind of things, what kind of progress has been made in that respect? And are there new materials that enable better quality?
Yeah. I mean, you raise a very interesting point. Finishing's always been a very big challenge in 3D printing. So there is one key point to touch upon. I mentioned earlier that I had my first SLA machine in 1993, and even then that was a 6-year-old technology. Everybody in the world nowadays thinks that somehow 3D printing was invented in 2011 or 12, and by 2013, 14, every school in the world was having a 3D printer installed and stuff. The reason there was this big boom in the promotion of 3D printing after 2011 is because one of the fundamental patents for one of the technologies expired for fused deposition modeling, FDM. FDM is actually one of the lowest quality of the technologies and has the worst surface finishing problems and remedial finishing problems. But those machines typically, the professional versions, they weren't too bad, but they were costing $35,000 up to hundreds of thousands of dollars. But when that patent expired, along came all these kind of hobbyists creating these tiny little FDM printers. And MakerBot was the most famous one. They had previously been called Rapman, then RepRap, and they were like a charity until the patent expired, and then they became a commercial business, and they started making these printers. Now the quality was objectionable, and you could only build parts that were very self-supporting and sort of organically self-supporting, designed to be built on one of these machines. If that was the case, then you could get parts off it, but a lot of the parts just fell apart, and hobbyists and home users bought them and realized, oh my goodness, this technology is nasty. I mean, they're just horrible. And the parts suck real bad, you know, and some of the materials like PLA were just nasty, you know. And so actually with this huge spreading of the word about 3D printing because of this FDM patent lapsing, and then the acquisition of MakerBot for $411 million by Stratasys at a time when they'd only sold $2 million worth of machines. I mean, it was a scandal. They got sued. It was fraudulent. They were horrible machines. They didn't work. And even 3D Systems got sued, who launched a similar copycat version of the MakerBot called the Cube. There was this huge boost in everybody selling these little home printers, but what it did was it ruined the perception of the surface finishing or the surface finishes of 3D printing, because by 2011, if you bought a high precision stereolithography machine or a DLP projector machine from someone like, let's say, Envision Tech, one of these sort of upside down stereolithography machines with a DLP projector, they're quite common as well now. If you'd bought one of those, the surface finish on those parts was actually exceptional. It was quite smooth and very high precision, and they were giving 3D printing a really good name. So the name of 3D printing got besmirched, if you like, from 2011 through to today. And that's a shame, because you can do much better finishing. That said, you cannot get away from the fact that these things are tessellated models. You know, they are stair-stepped models to some extent. Now, there are some technologies like Carbon 3D, which is technically an upside down stereolithography machine using a DLP projector. It's very, very similar to the Envision Tech machines, and there's lawsuits flying around on that subject. But what they did was they innovated having oxygen permeating the glass, and oxygen is an inhibitor of these photoreactive resins, so that when you were building upside down and you were converting resin here, it could pull back continuously and be growing continuously because it wouldn't get stuck to the plate. Normally you'd have to pull back and it would unstick, then you'd build some more and then unstick and build some more. But with carbon 3D, it is a continuous pull process, and therefore they can tessellate the model to very, very, very fine tessellations. And that means that you get a much, much, much smoother surface. It doesn't look like an injection molding. It won't, it doesn't. But you can even put textures on the parts now as you grow these parts on a carbon 3D machine. And that has allowed a lot of very low volume manufacturers to make parts on carbon 3D machines and use them for production, actually put them into production products, low volume production. So a lot of ATMs that are being built up in Scotland, I won't use the name, but they're being built by some former colleagues of mine in the UK on 3 of these carbon 3D machines. And these parts are made from polyurethane. That means it's an elastomer, but very, very stiff. And so you get these incredibly strong parts that can be self-textured during the build process. Much, much better. I would point you to Carbon 3D and their polyurethane builds. The surface finishes are exceptional on those.
What kind of machines do you use at your facility?
For the 3D printing, we do metal 3D printing, and I'm proud to say that I'm using a Renishaw AM250, which is made in the Midlands. It's a UK company who are famous, obviously, for their probing technology, but they bought into metal 3D printing about 6-7 years ago, I think, and they specialize in metals, and they specialize in the 250 millimeter build volume, and they're known for their high precision parts. So I had been in plastics before, and this time round I decided really to do metals because the bottom completely fell out of the plastics market. You know, as I say, you know, from 2011 on, with all these miniature printers coming on the market, and everyone and their dog, you know, had one in their shed. It was just, plastics was just murdered. And I just thought, I need to get into an industry, 3D printing industry, that still has a high requirement for skills, that isn't just a plug and play type of technology. It's got to be industrial style technology so that, you know, we're not going to get extinguished by Freds in their sheds at some point in the future, like the plastics guys did to some extent. And so I went down the metals route, and that also has synergy with our CNC shop. So we offer the ability to build a part in metal, 3D print in, say, titanium, aluminium, stainless, or a tool steel called Mar aging steel. And then we can hand it over to our CNC section, and they can do some secondary machining. So we can build a part that has really complex internal, you know, cavities or airways, cooling ways, whatever. And then there might be a few features here and there that need to be CNC machined to bring them to some kind of very high tolerance that you can't achieve with a 3D printer. And we actually call that process add sub, which is basically a mashup of additive and subtractive. So that's our add sub service. And it's quite popular with the orthopedic surgeons, maxillofacial surgeons. These are the guys who do the you know, usually the road traffic accident, or, you know, where someone's had their head smashed in for some reason, by accident, say. Also, we do a lot of work with like motorsport. We do nozzles for jets, all sorts of bits and pieces. You know, it's very broad kind of customer base, but there is a big challenge for metals, and that is this. If we talk about plastics, when I got into plastics, you did not have to worry about how you designed your part to be built on a plastic machine. You could put anything on there and you could build it. But with metals, you can't do that. With metals, there are so many more design considerations before you build a part. It's got to be very self-supporting. Everything's got to be at 45 degrees. If you build an internal hole, it's got to have a little roof on it so it doesn't collapse during the build. You've got to keep it thin walls, otherwise you get huge amounts of stress and the part can twist, even tear the entire build off the plate. So there's a lot more design considerations, and in a way that slowed down the adoption of metal printing to some degree. But the good side of it is this, that there's so much R&D involved in every build that once a client has given you a part to build and you've got the build working and they've modified their design to suit the process, it tends to be very sticky. It doesn't move from company to company to company, especially with the medical, aerospace, stuff like that. Once they lock onto a machine and a process, they tell you, you're not allowed to sell that machine for 15 years. You must only ever build it on that machine. You must never change the program. So you get locked into a program, and that's good in a way because the price gets locked down. So it's a much longer term development to fill a machine, but when you do, the work doesn't just drift away like it does in plastics.
If something's built up in the way 3D printing builds something up, it kind of, sort of using common sense, it kind of, I imagine that it's not as strong as an equivalent part that's made out of through subtractive processes. I do wonder how to overcome those challenges. They seem like insurmountable challenges, actually. But what kind of tools do the clients use?
Okay, so there's two sides to it. I mean, first of all, any 3D CAD system, whether it be, you know, SolidWorks, Pro-E or Inventor, or any of these, Fusion, for example, from Autodesk, any of these programs can be used for designing a metal 3D printed part. But the additional tools that they use to guide them to a much more efficient and organic part would be systems like Altair OptiStruct. Now, Fusion has a very similar system within it, and there's other systems have similar. What this does is, the first project I ever did was a slew plate for a mini digger back in 2001, working with a very famous backhoe laden manufacturer. I won't say the name, but basically this slew plate was about, I don't know, about 1.5 meters, 1.75 meters long, and it was made up, must have been about 50 plates all welded together, and it was very heavy. And they wanted to get rid of the weight, and they wanted to reduce the part count and make it easier to make. And it was suggested, the team that I was involved with suggested that they cast it in iron and or steel, whichever. I think it got cast in iron in the end. I can't remember anyway. But we gave the problem to Altair OptiStruct in the Midlands. And what they did was they said, okay, let's start with the packaging space. Okay, that's the packaging space. It must remain within that space. Let's give it the load points. Where are the moments? What, you know, tell us everything about what these various bits that fit onto it do and how they act and what the forces are. And then from those constraints and the packaging constraint and the connection points, we will allow the computer, through a process of evolution, to design the most efficient structure that will do all those things within that packaging space. And it was fascinating to watch because it basically starts off with a big nasty lump. And then it creates another version which removes any bit that wasn't really helping hold the load, and then removes some more, removes some more, removes some more. And then you see it kind of morphing around. And it takes about, I mean, by 1,000 cycles of the evolution, you start to see something that actually looks broadly like the final thing. And then you just keep going and going and going, and you end up, it evolves down different routes. Okay, so you might end up with, like, you know, shall we say about 50 different species. And then you look at these species and you think, well, which ones do I like? I like that one, that one, that one. You get rid of the rest. And then you further evolve them and maybe end up with some more species, and you pick a few more that survive, and so you go. Until after thousands of cycles, you end up with this very organic looking kind of structure that looks more like some kind of sea creature, you know. And then what you do is you import that into your 3D CAD system and you professionalize that shape that it's kind of created, you know, where it's gone up and around. Instead of letting it do this whole organic thing, you kind of professionalize it a bit, make it a little bit more boxy geometric. So when you've got that, then you can run some kind of, I've forgotten the name. Anyway, it'll come to me. You run a program on it to check whether it actually will survive the loads and do what it's designed to do. And then you cast it, you make one, you test it. And what we managed to do was we halved the weight of this thing, reduced it down to 3 components, and it was ever so slightly stronger than the original one. Now that was back in 2001. So you can imagine that these tools have got faster and faster and faster. So you can evolve much quicker. Instead of taking, you know, 3 to 6 months to do all that evolution I mentioned, you can do it in a couple of days now, and you can get some really fabulous structures. Now, why is that appropriate to metal 3D printing? It's appropriate because when you're building a metal 3D printed part, the time it takes to build is almost proportional to the amount of material that you are converting from a powder into a solid metal. And you're doing that with a laser beam. So you are heating up the metal, the powder, these spheroids, and you are melting it. You are effectively welding it. So when you think of a 3D printed metal part, don't think of it really as a layered part. It's like a sort of it's a bit like you're welding layer upon layer. So the metal really does actually remelt the layer below and fully homogenizes it, and you keep going and going and going. So you end up with a part that is effectively a 3D shaped weld. And anyone who's worked welds will tell you they're as tough and as strong as you could possibly imagine. In fact, they're too strong, too tough. And the one thing you have to do with metal 3D printed parts after you've built them is you have to heat treat them, anneal them, and so forth. Otherwise, they're so strong, they're not even malleable. You would snap them if you weren't careful, especially titanium, for example. It's super strong and very brittle when it comes out, and you have to fully heat treat it. So these organic evolutionary tools allow you to create the most efficient structure in the packaging space to cope with all of the loads and moments and torsions and so forth. And that means a lower cost part. And that's why metal 3D printing and these evolutionary design packages literally do go hand in hand. And we often see parts, when they're successful, they've probably been through some kind of evolutionary design development process.
Designing and manufacturing something is a hugely complex endeavor. I think you're probably mostly servicing customers who are doing individual components, and there'll be loads of other people developing components for an assembly further down the line, which brings it all together. Is that the case? Do you mostly produce components, or do you work with companies that are assembling a final item for which they're 3D printing lots of different parts through you?
Generally with the 3D printing, as you say, we are making kind of standalone components that will go into some bigger assembly that might include a lot of different manufacturing processes. But on our CNC machining side, our injection molding and stuff like that, we're more often than not actually providing a full kit of mechanical parts for a product. So we might be doing an entire you know, sort of breathing apparatus is one we just did recently. There was a ultrasonic scanner that we do for an American client, and we make all the mechanical parts, you know, whether it be sheet metal, stampings, injection molding, you know, the whole breadth. And in actual fact, that's what we specialize in is bring us all your mechanical parts and we can do them all under one roof. And they like that broad sort of Catholic service, you know, they really like that. But in the metal printing, you're right, it's more individual parts, because you don't make everything on a product by metal 3D printing. It doesn't make any sense. You use 3D printing like spices, you know, you use them, you know, a little bit here, a little bit there, sparingly, and only where you really need to, and you never overdo it because it's so expensive. So we, like I say, we liken it to the use of spices in cooking. You don't throw too much in, and otherwise you ruin the budget.
I do wonder sometimes whether straightforward CNC companies, of which there are probably quite a lot. I'm sure a huge number of them have now incorporated 3D printing into their service offering. I don't know if you can share any numbers in terms of, I know you said the number of employees, but I was thinking in terms of turnover and other kind of numbers of that type. I don't know if you can share any of those, but in general, what's the plan going forward? What do you anticipate happening for you in the next year or two in this business?
Yeah, so we're about $20 million US turnover. Like I say, we've got 300 people. Actually, one of the key points is I have, like any business in the world, I think, struggled to find good people and then retain them. Particularly, that retention's a big problem in China. So what we're doing at the moment is I've actually capped the number of people at 300. We've already been at 300 for a year, and we're going to be at 300 for another 2 years. That doesn't mean to say that we're not expanding our sales turnover. We're buying more technology, but we are doing an enormous amount of investment in training. So everyone in the company gets about 2 hours a week of training. For example, one of the things we do is we use Tooling University from the SME, the Society of Manufacturing Engineers, and every single person's doing at least an hour to 3 hours, typically average 2 hours on that, and a lot of technical training as well. And in the last year already inside our shop, we increased productivity by 50% with no new equipment in that period and no more people. And so in a way, it's a tactic on my part to force my people to become more efficient, you know, by just saying, look, if you want to bring someone in a department, you got to let someone go, you know, somewhere else in the business. And then they'll reach a point, maybe in about another couple of years, where we simply don't feel we can get any more productivity through technological acquisitions, new software, training, whatever, and then we can start growing the people. But as I say, we'll continue to grow the sales turnover. But there is obviously the consideration that, in my estimation, as a kind of a bit of an amateur economist, is I read a lot of economics, have done, read a lot of books on economics since the last financial crash, which I think a lot of people have, you know. Everybody became an amateur economist for the last decade, you know. And my reading of the situation is that we are on the precipice of an utterly catastrophic crash in the New York Stock Exchange. I mean, we're talking 1929, you know, depression territory here. The central banks of the world have invented $15 trillion out of nowhere. Good $5 trillion of that was pumped into the New York Stock Exchange since 2015. Last year alone, corporations in America borrowed near $1 trillion US to buy back shares, further pumping up the market for no underlying improvement. So the New York Stock Exchange is right on the precipice of a collapse, I think. Not to mention, I think the American economy is in for trouble. And when the United States gets a cold, Britain gets a cold, and usually the rest of Europe gets a cold. So my estimation is that towards the end of this year and certainly through next year, we're looking at some, some serious headwinds economically. So not to get into too much trouble over that, I decided to overhire in my sales team. So I've hired nearly double the number of salespeople that I would normally need. And a lot of them are still under 6 months service with my company. So they're just getting underway, But I feel it's necessary because I think we're going to experience a serious headwind, and I want to continue to grow through that headwind. And, okay, say I only get 10% growth or 5% growth. I'll be happy with that rather than, getting my teeth smashed in, with a 20, 30% loss of business, which is what often happens to industrial companies during those times, So it's kind of, I'm trying to stay efficient. I'm trying to keep a lean organization, and hopefully we'll weather it, but I just hope it's not as severe as, frankly, the runes are suggesting, I think,
You obviously make components and things for lots of other people, and it might occur to you to develop a product of some kind for some market of your own and assemble it.
Yeah.
You must have the capability to do so.
Oh, we have the capability, but I've been in the product development business, 36 years in a way, 25 years dealing directly with, developers of products. And there are very few industries more challenging and difficult as product design, frankly. You alluded to it earlier. It is difficult. And I see so many people who contact me or contact the company. And in the old days, up until 5 years ago, I would personally sit every morning and answer every incoming email coming through the website. I handed that over to some other people in my business. But when I was doing it, I would get people coming to me, and they wanted to put their houses on the line. They wanted to, sell the family jewels, literally sometimes. And they had the latest thing. It was going to beat the world. It was going to make them millionaires and everything like this. And I'd seen this so many times, and it was like trying to talk lemmings off a cliff. It really was. I mean, it's like, dude, don't do that. Seriously, don't sell your house, please, I beg you. But they get that imaginary smell of success in their nostrils, and they just head for the cliff. I mean, I have seen so many people ruined through product development. And when you consider the chances of being successful, let's say you are a highly successful design team with a track record, and you're designing and developing products. I don't know, Hewlett Packard or someone like that. They've got thousands of people working on new products. How many new products that they start work on and invest in initial concept and prototyping actually ever make it to the market? Maybe if they've got a really good team, they might get 1 in 10. But if you don't know what you're doing, you're lucky if you can get 1 in 100 to the market. I mean, they literally are not odds I would ever consider. So, okay, maybe I don't become a super rich guy, but I'd rather have a slightly safer life, a lower risk life. I'd rather make other people's parts for maybe a lower margin than take that risk. It's just, even venture capitalists say, even if you do all your due diligence, you make 10 investments where you've really investigated the team, you've done your due diligence, everything should be right. And what do you get from the average 10 investments? You might get 1 star. You get a couple that are, just okay, they kind of wipe their face, pay back a little bit, and then the other 7, throw them in the bin. Literally gone. So you're hoping you get a star out, 1 star out of 10 investments. And frankly, you'd be lucky nowadays to even get that.
It is a very, very challenging area, and but it is so tempting because we all, some of us anyway, thinking about making things, and the idea of product design and development is a wonderful route to go.
I could add just one thing to sort of talk to what does make, if you have an inventor, and I do see inventors who come to me and they have products that I call no-brainers. And a no-brainer is, well, yeah, why didn't anybody else think of that? And it's so obviously useful, and yeah, it's going to be successful. And you occasionally see these no-brainers. And the no-brainers come out of, for example, let me give you an example. We had a guy in Australia who laid concrete on floors. That's what he did for a living. He was a floor concreter, right? And one of the problems they had was you lay so much concrete and then you have to have an expansion joint, and then you lay some more concrete and then you have to have an expansion joint. And these plinths, usually what they do is as they shrink on one side or the other, they will randomly split, and it looks horrible. So he says every so often you've got to score a line across the concrete, and it's really difficult to do by hand. You've got to get it just right, and it's a very highly skilled job to make it look straight and neat and everything, so that when these bodies of concrete start to shrink, they will split exactly on that line. And then later on, you come back and you actually saw it and you put an expansion joint in or whatever it is that you do. But sometimes you just leave it as split. So he had designed a stainless steel, easy to clean tool that you just put on a normal, what would be like not a jigsaw, but like a sander. You fitted it to a sander. It just went backwards and forwards, right? It wasn't rotary. It just went backwards and forwards. And eventually, so we made one for him. He tried it. He did a video. And next thing he knows, he's got half a dozen mates saying, oh, I need one of them. Like really need one of them. Can you get me one? And he said, oh, Gordon, my mates want some. Yeah, okay, we can make some more. We said, can you make it a bit lower cost? And so it went, and we kind of helped them with the design and that. This guy sells hundreds and hundreds of these things to people in the trade all over the world. He was like the accidental inventor, if you like. He never came up with anything else, didn't really care about it too much, except for the fact that he could buy it from me for let's say, I don't know, 25 bucks and sell it for 75 bucks, you know? So that when he came to me with that, he had a real world problem and he had created a real world solution. And all of the guys in the trade are like, I got to get myself one of them. That's a no-brainer. And you see that, you do see it. It's not many. And these guys, they don't make out like they know anything about design. They let the experts guide them in that. If I say, go use this designer, they will. And come back to me when you need the parts, and they will. Because they haven't got any axe to grind, no chip on their shoulder. They're tradesmen, and they've come up with something that helped them, and everybody else wants it.
All the issues that we're talking about in this product design part of our conversation, make me, I mean, even before this, I often looked at Kickstarter and Indiegogo, some of these crowdfunding platforms, and see people with their little inventions and whatever. I do admire the fact that they've done so well as to bring it to the market in the first place. And often they're not particularly completely original in the way that you've just described. They are a version of another, existing product or design.
Sure.
But they're slightly more, interesting to look at, or have new functions or something. And they do really, really well. They raise a hell of a lot of money.
Yeah.
And to me, that is sales, because the raising of the money usually involves buying the product, right? So to me, that seems a success. I don't know what you think of that whole culture, if you like, because it is fairly new. It's probably emerged in the last 10 years or so.
Right, and I think it's excellent, actually. I think it's a fantastic discipline. And what I have done for years now, I tell these inventors, go on one of these fundraising sites, go through the submission process, and if you can't raise your minimum budget on one of those sites, you should not be putting your house on the line. You should not be putting your savings on the line. If you can't sell it to these people who are actually, to be fair, potential users and usually very altruistic in their intentions. Oftentimes people will put money into these things and they don't even really want the product, but they think, wow, what a cracking idea. I'll pop a few $100 or a few $1,000 into that because I feel like I want to support innovation. And I've said to them, if you can't sell it on there, you should not be doing this. You should really reconsider, back away from the edge of the cliff, mate. It's that kind of thing. And some of them do, but to be honest with you, most of them don't. They just labor on assuming they're going to be millionaires. But the guys who go to those markets, learn how to present, have to make the prototype. Actually, one of the things that changed with these sites was that in the early days, all you had to have was an idea. All you had to do was pitch an idea to get money. But they realized that too many people were taking the money and not delivering and really didn't have anything that even remotely practical to make. And so they upped their game, and Kickstarter was the first one to up the game, and they said, no, you've actually got to have a functional prototype before you can come on the market. And I think that was a very, very good move. That was a great move. But I love Kickstarter and all of those. They're fabulous platforms.
I agree, actually. Yeah, I do look in on it quite often, and once in a while I get a story out of it as well. Somebody's come up with a new robot or something, which I always try and feature on the website. And again, it gets a good number of visitors. There is a big culture about it, and we do get readers for those types of stories. All right, Gordon. Well, that was great. Great conversation, great interview. Appreciate it.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.